Okay, so some of you have noticed the pattern for finding the period of a function, but you may be wondering where it comes from. So let's look at this function and let's think about how we used to think about functions. We used to think about this. And each A, B, C, and D could affect the graph by applying some kind of transformation. So let's think about what this B value, which we see right here, used to do for us. Is it used to either horizontally stretch or compress the function, right? So it used to horizontally stretch or compress the function. Well, it still does that. So if we think about this 1/2, remember that it's always the reciprocal that we use to identify the stretch or compress. So the reciprocal is 2, and that 2 tells us that we are doing a horizontal stretch by 2 in this example. So if it's a horizontal stretch by 2, then, and the normal period of a sine function is 2 pi, then we could take 2 and multiply it by 2 pi to find the length of one period to be 4 pi, twice as long, right? Okay, well, let's apply that to this example. In this example, we have a 2, the reciprocal is 1/2. So that tells us we have a horizontal compress by 1/2. If the period of a cosine graph is usually 2 pi, but we compress it by 1/2, now we have a period that's only length pi. Let's look at one more example. Here, this tells us that we have a horizontal compress by 1/3. If we compress our usual period length of 2 pi by 1/3, we get a period of 2 pi over 3. So there is our period of 2 pi over 3. So where does 2 pi over b come from? Well, if we think of sine of bx or cosine of bx, we're thinking about a compress or stretch according to the reciprocal 1 over b. And the usual period is 2 pi. So if we think about that stretch or compress based on the reciprocal of b, 1 over b, we get 2 pi over b as our, quote, formula to find the period of a function. It all just comes down to our normal understanding of horizontal stretches and compresses.